go, class. What do you say back to me? Yeah, exactly. I'm just kidding. Okay, take out a highlighter. Doesn't matter. Take out a highlighter. If you don't have a highlighter, then you're going to ask your friend next to you once they're done highlighting to use their highlighter. Okay, we're going to go ahead and we're going to compare functions. This is actually stuff you've done in 8th grade off of the LEAP. Anybody remember doing multiple choice questions that said, what is the greater rate of change? Which one has a larger slope? What's the opposite slope? Do y'all remember that? And they gave you a chart and then they gave you an equation. Okay, that's what this is too. So number 1 says compare the following functions to determine which has the greater rate of change. First off, what is the rate of change? The rate of change is the slope. Go ahead, I want you to tell me, what is slope-intercept form? Y equals what? Okay, so y equals mx plus b. And the reason why this is called slope-intercept form is because it literally means slope-intercept form. Ooh, difficult, huh? Slope-intercept. So basically, the coefficient that's in front of your x is what your slope is. Everybody understand that? So using our highlighters, just to show that we know what the slope is, what is the slope for function 1? 3. Highlight the 3. Only the 3. Some people want to highlight 3x and say my slope is 3x. No, your slope is only the coefficient, not the x with it. Got it? What's our slope of function 2? A 5. Now, if I was to ask you which of these numbers is greater, what would you tell me? The 5 is greater, right? So same thing. The function that's going to have the greatest rate of change is function 2. Okay? Function 2. Okay, number 2, compare the following functions to determine which has a steeper slope. Now, we're talking about steep. I want you to think about this. Steepness, what have you heard that's like described as being steep? What do we talk about? A mountain, stairs, a hills. Okay, you can walk up a hill. What else can you do? Run down a hill, right? If I'm walking up a hill, I'm going to say that it's the same steepness as going down the hill, right? As long, like I might go down a little bit faster just because we start to roll, correct? But if we're talking about steepness, it's not whether we're going up the hill or down the hill that matters. It just matters how steep it is. Y'all got it? So same thing with rates of change. It doesn't matter the direction of my slope. All that matters is what is the slope. So for whenever I say what's the steepest, you just need to remember that your signs do not matter. So signs don't matter. So if I say this hill is -6 and that hill is a +5, then the hill that has the 6 is actually the steepest. Because negative just tells you the direction of it. Y'all got it? So just like a line, I could say that this is the same steepness as this line, except it's just pointed 2 different ways. Y'all see that? Okie dokie. Now this problem is extra special because why? What's up with this problem compared to this problem? Yeah, first off, which one really is my m? What number here? Yeah, the -6 is your m. And because d, it should have been replaced with x, but we can switch them out too. So everybody go ahead and highlight -6. What's your slope for function 2? +5. Now since we're talking about steepness, which one is steeper, function 1 or function 2? Function 1. What if I had asked, though, which one has a greater rate of change? Yeah, greater rate would have been function 2 because we do care about signs. So greater, your signs do matter. And you might want to just make a little note. Signs do matter. Okay? All right, compare the following functions to determine which has the faster rate of change. Now, faster is kind of just like steeper. You got it? Because if I'm going down a hill, a steep hill, I'm going to be going faster than if I was going down just like a normal hill, right? Okay, so for this one also, your signs do not matter. And once again, the rate of change is the number that's in front of our x. Everybody got that? Okay, so let's highlight. What is my rate of change for function 1? -5. What's my rate of change for function 2? Positive 1/4. So which one has the fastest rate of change? Yeah, function 1. But remember, if I had said greater, then what would my answer have been? Yes. So greater is the only one where sign matters. Y'all got that? Because greater, you're actually talking about number-wise. Everybody understand? But steeper and faster, it doesn't matter the direction that the line is pointing. All that matters is what the line is doing itself. Okay? Let's go ahead and move on to our next slide. And I want you to go ahead, I want you to take just a few seconds to copy this down in your notes also. Okay, which has the greater slope? How do I find the slope of a table? Who remembers that? What can I do to figure out what this slope is? Very good. Rise over run is correct. Do we have a formula for that? Subtract our... Very good. We subtract our y's over our x's. Let's all do that with our hands right now. Subtract your y's over your x's. One more time. Again, subtract your y's over your x's. Now, it does not matter which 2 points you use first. In fact, I can use these two. I can use the last two. I can use these two. It's whatever you want. Because as long as it's a linear line, the slope's going to simplify to the same thing. Y'all got it? So, and how do I know, just since I said that from last week, how do I know that table's linear? Well, the f of x just tells me it's a function. How do I know it's linear, though? Yeah, it's increasing in a pattern for the x's and the y's. Do y'all remember that? Okay. Very good. 1 for x and 3 for y. Okay, so which has a greater slope? I'm just going to do these 2 points, okay? Boop, boop. So let's go ahead and subtract. What's my first y that I see? -4 over what, y'all? 0 minus 1. -3 over -1, 3. So my slope for my chart is 3. Y'all got it? So f of x, the slope is 3. All right, let's figure out what the slope is for g of x. What do I need to do again? I can do the same thing that I did up top. Yep, you just get your 2 points, find 2 points, and then subtract your y's over your x's. So 1 minus 4 over what? 0 minus 1, then what? -3 over -1, which is 3. So what is my slope for g then? So which one's greater? They are the same. So I was trying to trick you. What would we put to show that they're the same mathematically? What symbol says equal signs? Good job. Good job. Okay, number 2. Which slope is the steepest? That's kind of a trick question. Why? It's the same slope. So if it's the same rate of change, it has to have the same steepness. Y'all got that? So it's equal also. Or you can just write same. Now, number 3 says, which has the larger y-intercept? And this has been confusing people, but how do we find what a y-intercept is? The y-intercept is where what equals 0? Where x equals 0, correct? So what is my y-intercept of my chart? Where does x equal 0? At 0, 1, right? So my y-intercept here is 1. Do y'all see that? What is my y-intercept of this graph? 1. How come? Yes, because that's where x is 0, right? And y-intercept means on the y-axis, where it intercepted on the y-axis. You got it? Okay, so what do you notice about those two y-intercepts? What conclusion do you think you can make? Very good. They are the same exact line, but just two representations of that same line, right? Here I have the line in a chart. Here I have the line on a graph. Can't sneak anything past y'all. Any questions? All right, let's go ahead and move on. And I'm going to go ahead, I'm going to let you copy this one too. All right. Okay, which function has, I don't think they heard that. Which function has a greater y-intercept? First off, what's a y-intercept? Where what equals 0? Where x equals 0. So what is my y-intercept for g? 2. How come it's at 2? Because it's counting by 2's. Yeah. Okay, how am I going to figure out what my y-intercept is for f? Somebody said it's the number in front of x. Is that correct? No, because that's your what? That's your m. That's your slope. Which one is your y-intercept? The 1, because remember, it's slope, intercept, form. If we forget that, then just make x equals 0. So what is 2 times 0? Plus 1 is, so you get the same answer. You see? Okay, so your y-intercept for g is 2. Your y-intercept for f is 1. So which one is greater? G of x. Good job. All right. Which function has a greater x-intercept? What's funky about g of x? It has how many intercepts? 2 x-intercepts. Because x-intercepts are where what equals 0? Where the y equals 0. Also, where are x-intercepts located at? On the what? On the x-axis. Very good. So what is just one x-intercept on this graph, Kaylee? Good job. Pick anybody else in the classroom to tell me what the other one is. -2. Very good. It's where it's at on the x-axis. Okay, how am I going to figure out what my x-intercept is for f of x? What do I make 0? You make the y 0. What is the same thing as y? F of x, right? So I can make that 0, and then I just solve it in order to figure out what my x-intercept is of this problem, okay? What would I do in order to solve this? Subtract 1. Then you're going to get -1 equals 2x. Then what do you do? So what do you get? Oh, awesome. You're going to get -1 over 2. So which function has a greater x-intercept? Which one? And which x-intercept is the greatest? The 2. So just that part's actually our answer. And you would just write g of x. Okay, which function has a maximum value? Now, a maximum value is something that we haven't talked about yet this year. But maximum, what do you think maximum means when it says you've reached the maximum? The highest value, right? The highest capacity. How can I say the maximum value for a graph? What do you think I'd be talking about? Yeah, the highest point. Will this graph ever go any higher? No. What's the highest it goes? 2. How come it'll never go any higher? A little bit more. Explain a little bit more. Not just, it decreases. Very good. That was right. Because it always decreases because of the arrows. Y'all see that? So this is a maximum value. Does everyone understand? Because it will never get higher. So g of x has a maximum value. Now let's look at f of x. What kind of equation is f of x? We learned about it last week. Which, if it's slope-intercept form, then what does that mean? What kind of equation is it? Linear, because it makes a straight line. What are our qualifications for it to be linear? Can't have an exponent. Has to be separated, and variables can't be on the bottom. Very good. Y'all remember that last week? So this one is linear. All right, if it's linear, it means it's always going to be a straight line. How come this would never have a max value? And what do the arrows mean? Yes, it'll never reach its highest point. Do y'all see that? And it'll never reach its lowest point either. Do y'all see that? Because it keeps on a going. All right, so g of x is the one that has the max value. Does everybody understand that? This is called a parabola. Everybody say that together. Parabola. Beautiful. Okay, and we're going to learn more about that in January. You do not need to copy anything down. In fact, we're just going to talk about this one together. So, let's look at the first question. Which graph has the greater initial value? I'm going to call this f of x, and I'm going to call this g of x. Now, you probably can't see it too well in the back, but f of x, this is about my weight. And this person starts at 60 pounds, and they keep on increasing and decreasing all the way to 70 pounds. Got it? Hopefully that's like a third grader, because that should not be anyone in the 9th grade that starts at 60 pounds. Here, this is the absent days for Jim in elementary school. So this is how much Jim missed. So Jim went home and he was like, you know what? I want to make a chart of how many days I was absent. Just like y'all all do when y'all go home, right? Yeah. Okay, but this is his little line graph of it. So he starts with missing 3 days. And by the 6th grade, he's missing 1 day. All right, so let's go back to our question. Which graph has the greater initial value? What does initial value mean? The starting point. Which one starts at the higher point? F of x or g of x? Why f of x? Good, because it starts at 60. Okay? Which graph has the greatest rate of change between the first and the second point? The first and the second. You're right, f of x. And let's go ahead and explain why. This is the point 60, right? And this is point 70. So I went up how many? I went up 10 and over what? 1 month. Y'all see that? So up 10 and over 1 month, which is just 10. This slope, I went up 1 and to the right 1 grade. So 1 over 1 gives me my slope of 1. So still f of x is right. Do y'all understand that? Okay, explain which graph has an x-intercept. Which one has an x-intercept? F or G? F or G? Why G? Very good, because there's a dot on the bottom. That's what they said. Your x-intercept is where it's on your x-axis. Does everybody see this point? Can you see this point from where you're sitting? Okay. This is the x-intercept. Now it says explain in words what it means. This is just review. How can I say what this point means on this graph? What would I say? Very good. Do you want to say it louder into the mic so everybody can hear you? No, you said you're good. Okay, but he was right. He said in Jim's 5th year of school, he missed 0 days. Good job. Okay, explain in words what the graph relating to weight did. Use increasing, decreasing. All right, so from July to August, what'd she do? She increased. Then what did she do? She stayed the same. Then what happened? Increased from September to where? Some people said September to October. Is that right? Where did she actually increase from? September to November. Do y'all see how it starts taking? That's because her rate of change yeah. This was faster. This is a slower rate of change. Right. Because if I went down this hill, it would be way slower than going down this hill, right? So it's still increasing. It's just a different kind of hill, if that makes sense. A different slope. All right. And then from here to here, what'd she do? Decrease. All right. Let me ask you a question that's not on here. What do you think is steeper? Do you think November to December was steeper, or do you think October to November is steeper? November to December. Which one would be faster? Yes, November to December, because the steeper it is, the faster it's changing. Y'all got it? What do you think steeper? The 4th to the 5th grade, or November to December? Yeah, 4th to the 5th grade. Can you imagine rolling down a hill like that? You'd be falling. All right. Any questions on how to do this? Y'all got it? Okay, the last thing. This is the second to last slide that you got to copy, so it's not really the last thing. I want you to go ahead and copy this, and then I'm going to give you a few minutes to answer it by yourself. All right? So go ahead right now and just copy. So for our first problem, raise your hand if you know what the slope is for the first function. Jasmine. 3. Very good. How come our slope is 3? Because it's next to the x. Very good. So 3 is our slope. All right. Who knows what the slope is for the second function? All right. I'm seeing some people say 2. Is that correct? No, it's not 2. How come it's not 2? Because what has to be by itself? Y has to be by itself in order to say it's the number in front of x. You got it? Do you understand that? So let's go ahead and move y by itself. Or not move, get it. So what would I do? Minus 2x. All you're doing is isolating y. Do you understand that? So you move over your friend. So then you would have negative 4y, negative 2x plus 7. Then what do I do to get y by itself? Divide everything by negative 4. Now, as long as y is by itself, you're in slope-intercept form. So 1/2 x, because I can reduce, minus 7/4. So now, what is my actual slope? 1/2. And I got 1/2 by reducing the fraction 2/4. Y'all got it? So which one is greater? The first or the second? The first. All right. Number 2, the y-intercept. How do I figure out what the y-intercept is? Make what equal 0? If you don't know that, you need to write that next to your paper in your notes. For y-intercept, you make x equals 0. All right, so if we make x equal 0, what is 2 times 0? Minus 5 is? So this y-intercept is negative 5. Here I'm going to make x equal 0 here. So what's going to happen, though, whenever I do that? What is 3 times 0 plus y equals 10? What? Just 0 kind of cancels out, right? Nope, you don't have to move over y. I mean, you could if you want, but you don't have to. Yeah, you don't have to do that, but if you wanted to, you could. And what would you get? Y equals what? 10. So who's bigger, the first or the second? The second. All right, third one, x-intercepts. And somebody, y'all had just asked, do we have to get y by itself to find x and y-intercept? No, only for your slope. You got it? So x-intercept, what do I make equal 0? The y. So I'm going to have negative 2x plus 0 equals 10. Well, anything with the 0 goes away. So what would x have to equal, y'all? Y negative 5. Very good, because you would divide by negative 2. Raise your hand if you understand that. All right. Next, what am I going to do? Make x equal, I'm sorry, not x. Make y equal 0. Tricked you. All right. Anything times 0, just what? Yeah, it goes away. So if you divide by 4, 2. So which one has the larger x-intercept? The second one. Here signs still matter because we're talking about greater than. Got it? I'm not saying what's steeper. And this isn't steeper. This is x-intercept, so it has to be greater. Okay, number 4, the rate of change. So, Tyler, what is my rate of change for this problem? Very good, because it's what's in front of x. Cameron, what's my rate of change for this problem? Is that right? Is it just 2? Why wouldn't it be just 2? What do you have to do first? Yes, you have to get y by itself. So who would you move first? Who would you move first to get y by itself? So since it's positive 2x, what's it going to be when I move it over? So I'm going to have what then? Y equals plus 7. Now since x is by itself, who is my slope? Negative 2. What do you notice about these two? They're equal. So that's the symbol you put in between. So if you need little bitty notes, in order to find the slope, you have to have it in y equals mx plus b form. That makes your life so much easier. To figure out the y-intercept, you make x equals 0. To figure out the x-intercept, you make y equals 0. For the rate of change, again, you want it in this form, and it's always going to be your m, just like the first one. Same process over and over and over again. Any questions? Okay, the first problem says the greater rate of change on this interval, negative 3 to 2. So I'm not looking at the whole graph. It's like if I was to cut a piece of the graph off, I just want to know what is the rate of change between negative 3 and 2 on each of these graphs. Y'all get that? So how did I tell you that what formula do we use in order to find the rate of change? Subtract your what? Your y's over your x's. Now what's up with this though? Do I have a y? No. So guess what you have to do when you have an interval? First, you find your 2 points. So what you're going to do first is you're going to put negative 3 into f. So you can say f of negative 3 would equal, if I put negative 3, what would that be? 9. So what is my point there? What did I put into the function? Negative 3, and I got out 9. That is my first point. Make sure you are paying attention. Yes, question. Okay, I got 9 again. By doing negative 3, you just plug it into f. That's it. That's your first point. What you plug in, what you get out. So let's do the same thing with 2, because I got to have my 2 points. All right. So what am I going to get when I put 2 in for f? 4. So what is my point? 2, 4. Those are my 2 points for f. Now all I do to find the rate of change is subtract the y's over the x's. Do y'all get that? Okay, so 9 minus 4 over negative 3 minus 2 is going to give me what? 5 over negative 5, which is negative 1. So the rate of change of f on the interval negative 3 to 2 is negative 1. That's the rate of change. All right? Let's go ahead and do G now. I'm going to change up my colors. So before I can figure out what my slope is, you have to first find your points. Does everybody understand that? Okay, so for G, I'm going to plug in first this one, negative 3. So G of negative 3. What do I get when I put in negative 3 for G? Negative 9 minus 1 is negative 10. So what's my point? What did I put in? What did I get out? That's my first point. What's my second point going to be? G of 2. And then when I get G of 2, I get 5. So what's the point? Quickly. What's the point? 2, 5. Okay, now what do I do in order to figure out what my slope is? Y's over our x's. So I'm going to say negative 10 minus 5 all over negative 3 minus 2. So negative 15 over negative 5, which is what, y'all? 3. So who has the greater rate of change, F or G? G. Okay, smaller y-intercept. How do I figure out the smaller y-intercept? Make x equal 0. So what would my y-intercept for f of x be? 0. What would my x-intercept be for g of x? So which one is smaller? G of x. How do I figure out my x-intercept? Make y 0. So if I put this equal to 0, what number squared gives me 0? 0. So your x-intercept is 0. If I put this equal to 0, you would have, and if you solved it out, what would you have? Oh, that shouldn't say f of x. What would we have? 1 over 3. So this one's bigger, g of x.